The Bradford Research and Extension Center, BREC, lies just east of Columbia, Missouri, and is used for substantial research within the School of Natural Resources. Students and faculty here at Bradford Farms help to provide fresh-grown vegetables for the University of Missouri, as well as help compost the 270 tons of food waste per year that is produced on campus. When asked, Mr. Reinbott says that it takes a good year for most composts to break down and get to the right carbon and nitrogen ratio. BREC is using a low-tech system where they will compost waste aerobically by mixing a 1-to-1 ratio of animal bedding and food waste to each system. About 2 tons of waste can be added each day as a compost using this aerated system. Students and faculty here at Bradford Farms have utilized PVC piping to line the middle of the system. This way, air can reach the bottom of this waste to speed up the process of composting. Another important and interesting project here at BREC is the recycling of the 3,000 gallons of vegetable oil that the University of Missouri produces each year. Students are converting this vegetable oil into biodiesel that will be used to transport grown food and wastes to and from the farm, giving the Bradford Research Center a closer to zero carbon footprint. Let's go talk to Mr. Reinbott.
Well, it just so happens that food waste and horse bedding are a great combination to make compost out of. Carbon to nitrogen ratio of 30 to 1. And that makes the bacteria and the fungi happy. If you get out of that range, you'll do like what we smell right now. The students got to outrange us a little bit. So, food waste is about 20 to 1. The horse bedding is 40 to 1, so a 1-to-1 ratio works great. So we started doing that. First of all, we had to get a facility built. And we wanted not just composting, you can do this just by mixing it up, throw it on the ground, it'll eventually turn into compost. But the more you turn it, the faster it goes. Well, our idea was, let's do it for a week and get it done in a month versus years or months, a month. What we want to do is that we want to mix it up, so we have this in this mixer. We get it mixed up, we'll put it in these bays, and this should hold a week's worth of food waste and all the stuff from campus. A week's worth. And we can inject air through it and or suck air through it, inject or suck, and speed this process up. So the students are getting ready to do another one of those. They got to get new pipes as it broke up. But what it is, this pipe has holes in it, and they can push air through it, or as I said, suck it through, and this will speed the process up. And this is some of the compost that's just about done right here. This was probably late last spring semester. So it's not going as fast as we want, but we're getting there. And this was food waste and all that. And what another student is building, it's right over here, is a screener that we can screen this and get the fines out. And the fines are worth a lot of money compared to the bigger chunks need another month or two, and we can take that then, and hopefully students like yourself can bag this and get some value added to it.
What are the fines?
Oh, that's just the stuff that's really composed, that's ready to roll. Where the larger stuff, it needs a little more time.
Gotcha.
So if we could do that, we could really value add this. Now we use biodegradable bags in this whole system, to keep it clean. We have there on campus, and they do break down, but they're a little bit slow at times. So you can see we still have a few pieces of bags in there, but they will break down.
That's cool.
Now, is all the compost applied, or do you have excess?
We have excess compost. We applied a whole bunch last spring, and we can apply some more this fall. But really, we produce a lot more compost than what we can use.